Hey guys, you're welcome to this video. In this video, I'm going to be explaining and taking you through how to create upgradable smart contracts with Solidity. Normally, smart contracts are immutable, which means once you deployed your smart contract to the blockchain network, you cannot modify their code, you cannot um, do normal things that you do with in the normal software development environment, like when once you deploy a code, you can to a server, you can fix the if you have a bug, you can like fix and deploy again. But with smart contracts, if you deploy again, you are going to be having a different address, which is kind of not good enough for dApps where because users will are kind of slow to migrate from an address to another. So that's why the concept of upgradable smart contracts came up. So upgradable smart contracts, you can modify their code while preserving their address, state, and balance, which means their address, the smart contract state, and the balance will not be changed, even though that's a new code entirely. So let's see how we can create that. So in this video, I'm going to be using the Open Zeppelin library to create an upgradable smart contract, and we'll see how it works. So I'm going to be using AdArt with my VS Code. So let's get started. So the first thing I'm going to be doing is to set up my environment. So I'm going to initialize the node project using yarn init. So as you can see, we have our package.json. Then we also have our .env file. So basically, .env file, I use it to like hold my environment variables. I'm not going to be exposing them in this video. So now let's initialize let's install AdArt. So you can say yarn add art. So let's wait for the installation to complete. Okay, so we have AdArt installed now. So let's initialize AdArt project by saying npx AdArt. So we're going to be doing some selections. So we are installing some dependencies that comes with the sample project. So let's wait for the installation. You can just ignore this warning, blah blah. Okay, now that we've installed that, I'm going to be installing some dependencies and I'm going to explain what they do. So let's say yarn add. So we are going to be installing the Open Zeppelin contract library. Open Zeppelin. So just a library of pre-written Solidity code that we can use in our projects. Then we are going to be installing Open Zeppelin. Open Zeppelin contract upgradable. So it's just like a variant of the normal contracts, but for upgradable smart contracts. Okay, then we're going to be installing Open Zeppelin add out upgrade. So it's an add out plugin for for deploying upgradable smart contracts with add outs. And lastly, we are going to be installing Nomic Labs add Etherscan. We are going to be using this to verify our smart contracts or interacting with Etherscan. So let's install those packages. Okay, I think there's a typo here. Open Zeppelin. There's a typo here. Let's remove that. Okay, so let's wait for the installation to complete. Okay, lest I forget, we are going to be needing a library to load our env variables into our into the node runtime. So we're going to be installing let's use yarn add dot env. Okay, so while that is installing, so let's come to the add config file here. And this is where we're going to be. So I'm just going to remove all of this because I don't need them now. Okay, so this you might not need to do it, but I have Dino installed on my machine, so it's going to be interfering with my Node.js runtime using my VS Code. So I'm just going to disable it for this workspace. Settings. So you might not need to do this actually. So I'm going to be setting it to 4. So I think we have that now. Okay, so let's import. Let's just load some package that we need. So we are loading add Etherscan. We're also loading Open Zeppelin add upgrades. So yeah. So then we're also loading the .env. So we do .env .config. So that's it. Okay, yeah. So let's specify our networks. So networks Then here we are specify link by. So basically we'll be deploying to the link by testnet. So URL, I'm going to be using we are going to be using Infura. So let's enter the node URL space and link by the Infura the IO slash 3. Then I'm going to be appending appending my what's it called, my project ID, my Infura project ID. Okay, yeah, so now let's add some accounts that we are going to be using when deploying smart contracts. So dot private key. Then let's also add Etherscan configuration there. So API key using process Etherscan API key. Basically, all of these environment variables are here in this env file. So let's basically, you can do that on your own too. So, okay, so I think we are done with this configuration file. So if you have any problem, we'll be getting back to it. So in this video, I'm going to be creating a book smart contract, but the contract will be upgradable, and we are going to be seeing how that works. So let's delete this one that comes with the added packet, and let's create a contract called book. So we are going to be specifying our license. So I'm going to be using MIT, then our pragma statement next. Specify the version. So I'm going to be using Zoom. So then say let's create our contract here. Contract book. So basically, in our smart contract, we are going to be having some state variables basically. So I'm going to be naming the state variables name, which will be the name of the book. It's going to be a public variable, will be name, and then also have the number of pages, we went to 56 public pages. So this is the number of pages in the book. So then for upgradable smart contracts, we do not need a using constructors. Okay, so let me go like this. So basically, once you deploy a smart contract, in the normal settings, we can have a constructor which is going to be called whenever a smart contract is deployed. But for upgradable smart contract, the constructor poses some limitations and restrictions, which I'm not going to be talking about in this video. If you want to know more about the limitations of using a constructor, you can check some resources online. Also, I'll check the OpenZeppelin documentation about upgradable smart contracts. Okay, so what we are going to be using instead is use a function which will be run instead of the constructor. So basically, it's a convention to use a function called initialize. So basically, it's going to be run just once, and it should not be able to be run again. So basically, let's see that. So we have a function. Function is initialize, and it's going to be a public function. Yeah, and this is it. So basically, we want to accept two parameters, which will be the name, string memory. Then also accept the pages, 256 pages. And so we are going to be setting the state variables there, name, and then pages. Okay, so yeah, so normally this function can be called over and over again, even after the smart contract have been deployed. But we do not want that. We want it to be called just once. So you can literally just do have a state variable here that says that tracks whether this function has been initialized or not. But we're not going to be using that. We're going to be using add open Zeppelin upgradable Open Zeppelin contract called initializable. So let's see that import. So we are going to be using Open Zeppelin upgradable. So Open Zeppelin / contracts upgradable and / proxy and / utils, then initializable .sol. So this is the contract that we need. Yeah. I think okay, let me just quickly confirm this. Open Zeppelin contract available proxy utils initializable. Okay, there was a I forgot that I okay, yeah, that should be fine now. Okay, so we are now going to be extending our book smart contract with this initializable. So you can say it's initializable. So we should now be able to use a modifier called initializer. Initializer. Okay, yeah. So basically, this initializer, what this does is that it makes sure that this initialize function should only be able to be run once, and after that's when the smart contract has been deployed. So after it's been run, when it's been executed, we should not be able to call it again. So now let's look at how to deploy the smart contract. So it's really easy. You can come here and say let's create a new script called deploy v1.js. So we are going to be needing the other environment. So let's sorry for this. So let's see import add ads. So I'm going to be needing itas and upgrades. So let's create our main function. Const main post it's going to be an asynchronous function actually. Async, and then so let's just call it in case of any error, just catch you can console log the error. Okay, yeah, so we have this now. So what I'm going to be doing first is that I'm going to fetch the contract factory. So say equals to await itas the get contract factory and the name of the smart contract, which is book. Then the next thing we're doing is we are going to be deploying this function. So const book equals to await upgrades instead. So we are going to be using upgrades. So normally we can just use when we're deploying normal smart contract, we can just do book.deploy and we pass in any argument that we have, but this is an upgradable smart contract. We're going to be using the upgrades instead. So upgrades are deployed proxy. So basically there are different types of upgradable smart contracts, which is out of scope of this video. I'm not going to be going to that. So book, we are going to be passing this contract factory here. So then the next thing is that if you come into the smart contract, you see that you're accepting two parameters. So which is the first one is the name of the book, and the second one is the pages, which is an integer. The first one is the name, which is a string. The second one is the number of pages, which is an integer. So we are going to be passing it here as an array. So let's name the book of life, and the number of pages should be 1000. And then so we have can pass an option, and so we are going to be passing the initializer option. So the initializer should be pointing to this name of this our initializer here. So we have it initialize. So let me just, I've copied it, and I'm going to just paste it. So that's the name of our initializer function. So let's just ensure that the smart contract is deployed. I will deployed, and can just also the log book contract deployed at book.address. Okay, yeah, so now let's try and run our smart contract deployment. Okay, yeah, so let's run the script. So you can see npx add run. So let's specify the network. It's going to be linked by, and then we pass in the scripts slash script deploy v1 v1.js. So let's see. Okay, yeah, so I think everything's going well. I think it's okay. Yeah, so our smart contract has been deployed now. So let's try and view this smart contract on the network. Okay, so I have the other stuff here. So the MetaMask. I'm using my MetaMask address actually. So I just imported the private key into my environment variable. So I should be able to access the address of the my network through MetaMask. Okay, so let's view account on Etherscan. Taking, let's wait for the transaction to be reflected on the blockchain network. Okay, yeah, you can see now that our smart contract have been deployed. This is 1 minute ago, and this one is 53 seconds ago. So yeah, our smart contract have been deployed. So let's see our smart contracts. Let's see them individually. Okay, so this is our smart contract that the actual implementation of the smart contract itself. So we've not verified it. So then we also have this smart contract, which is the proxy admin smart contract. You can learn more about that on the OpenZeppelin smart OpenZeppelin upgradable documentation. So then we also have the upgradable smart contract, upgradable proxy itself. The type is transparent upgradable proxy. So basically, like I said before, we have different type of upgradable smart contracts. Okay, yeah. So let's now verify our smart contract on Etherscan. So to do that, I'm going to copy the address of this one that we deployed actually. Okay, so I'm going to copy this and want to verify the address and the contract. So since we already specified our Etherscan API key here, so and also we installed the added Etherscan package here, and we loaded it. So I'm going to be running npx add verify. So verify slow network link by then paste in the address. Okay, so let's see that. Yeah. Okay, so it's working. So let's see how it goes. Okay, yeah, so we successfully submitted our source code for verification. So let's wait for the results. Okay, yeah, so our smart contract have been verified successfully on Etherscan. So if we refresh this, okay, so we have it. Okay, so if we like try to read the contract, we'll be seeing that we can't read it. So basically these are just empty states, and so basically this is just like the implementation itself. So let's connect it to with the proxy. So if you come in now and say want to read contract, okay, so I'm coming. And okay, yeah, so basically this is where we'll be working on it. So we'll come back to our transparent upgradable contract itself, which is the, as you can see, a transparent upgradable proxy. So let's connect it to okay. Firstly, if you try to read or write the contract, you'll see there are no available contract ABI, and same thing for the write contract. So what we can do is we can connect it with our proxy. We can connect as a proxy. Since it's a proxy contract, we are going to be connecting it with the implementation. So click verify. And okay, yeah, so it's being verified. Okay, so let's save. Okay, yeah, so it's been done now. So let's go back to the contract itself. So now if we come back in, we can now read as proxy, write up as proxies. So okay, you can see now that this is the string that we pass as a parameter here. If you come to this deploy beyond the book of life, and the number of pages is 1000, as you can see here. So then it comes to the right proxy. You should see this. Basically, you should not be able to call this again since we've already initialized the contract before. Okay, yeah, so now let's write an upgrade for the smart contract. So let's have book v2 dot sol. So I'm just going to like copy this and paste it here. Then I'm going to remove this. Still I should remove this too. So book v2. Well, you can leave them. You can actually leave them. There's no problem with that. But I just okay. Let me just. Okay. So I'm just leaving them. Okay. So we should want to add. Want to update. Okay. So basically, in the first contract, we forget to have functions to set the name and the pages of the book itself. But so let's add a function to be able to do that. So function set. Let's say set. So we have string memory. We pass in the name, and 56. We have the pages. So then it's going to be a public. So let's I'm going to be setting this because name, then pages equals to pages. So we forgot to add this set function here. Let's say it's a bug that we forget to add this. So now that we want to quickly upgrade our smart contract, so even users don't have to know that there was a bug. So let's now deploy. So we can create a new upgrade v2 dot about .js. Then so it calls task cost require at task. Then also upgrades. So like we did before, let's have our main. Let's go on async variable, async function, and let's just call it this is when I was shift and that's what I need to do. So let's load the contract factory. Load v2 equals to require it has dot get contract factory load v2. Then let's upgrade it by saying await upgrades dot upgrade proxy. Then so which proxy are we upgrading? So we're actually upgrading this proxy. So let's copy the address here. And let's just add the percent to variable constant proxy. So let's upgrade our proxy and the book v2. So this what we need to do. Okay, yeah, so let's do let's try to run this the upgrade v2. Okay, yeah. So it says book. Can't find the artifact. Okay, okay. So the problem is that the artifact actually looks for the name of the contract here. So let's name the contract to v2 step 2. So yeah, let's have it. Cannot read properties undefined. code deploy. So so let me just quickly go what will be the cause of this error. So basically, we are prone to get errors, and that shouldn't freak you actually. Okay, yeah, so that shouldn't freak you. So let's just do the and upgrades. Let's add that. So not so sure why this is happening, but let me just quickly. Okay, well, I think it's here. We are not awaiting this. We should be awaiting it. I think that's the problem. So let's see again. Okay, so let's wait. Okay, I think there's no error now. So let's check the data scan. Still, it's not affecting on data scan. So let us wait for some time. Okay, yeah, so we have it here. So it's deployed here. So let's just as you can see now, we have this here. So our smart contract, our upgrade smart contract has been as you can see here that we are calling this upgrade upgrade method, and it was 14 seconds ago. So let me just use this. Okay, so what we're going to be doing now is I'm going to be verifying this contract that we just deployed here. Okay, so let's like open the transaction, and we have this contract here. So okay, so this is the proxy admin. So I'm just like trying to okay um I think I should be logging okay. Just some okay, yeah, so this is the contract that I'm actually looking for on my pad. So this is it. So instead, what I'm going to be doing now is I'm going to verify this smart contract too. So let's verify this. So let's verify this contract. Okay. Okay, so the contract has been verified now. So let's try refreshing the page. So as you can see now it's been verified. So let's try this again. Um, yeah, so you see that we now have this additional function here now, but the address doesn't change. So we can just okay, so let's initially when we deploy this contract, you see that everything here is the book of life, like we actually already did. So now that we deployed an update to the blockchain, so we now have a new function that we just deployed. As you can see, it's here. So let's just reset the name. So the main book, the main book. Let's set the page to 500. So let's first connect our MetaMask. Our MetaMask connect. Okay. So I'm confirm that it's been connected. So I'm connecting these accounts. So let's write. Okay. So let me just refresh the page again and come back to this contract section. So set the name to the main book and the page to 500. Let's connect our MetaMask. Okay, so let's run some next. Okay, as you can see now, you can update it by. Okay, so let's confirm this transaction. So you can view your transaction on Etherscan again. So basically that's it. So transaction is still pending. Once the transaction is confirmed, if you come back to read the proxy, you will see that this name has been has been updated, and the pages too have been updated. So basically, that's how to use Upgradeable smart contracts. So it's actually more than this, but this I hope this will give you a basic introduction, to what Upgradeable smart contracts and how we can create one. Thank you.